Okay, so I checked this. I basically checked that you finished each problem. We did 1 through 12, and then we just need to add the summary for the trinomial with an a, meaning a coefficient. So if you have a number in front of x squared, so whenever we see a number here, one way we could think about it is you're gonna slide that number in the front and multiply. So our summary is whenever when there is a number in front. Okay, anytime we have a number in front, we're going to do the following three things. We're going to slide, oops, sorry, did that wrong. Slide that number to the front and multiply it to the back. So what that really means is I'm going to put in parentheses, we're doing A times C. C is your last number in the trinomial. So you slide and multiply. Then you're going to divide to simplify it and reduce the fraction. You'll always end up dividing by the number in front, the A. The last thing is if it doesn't reduce, if you cannot simplify, if you can't reduce or simplify, just remember that the bottom number comes up. Bottom up. Kind of ran out of room there, but some of you, I think there's only a couple that messed up on that, forgot to reduce one of the factors. So an example of that, the bottom up, let me extend the page so y'all can see it, sorry. Example of our bottom up is when we had on number, I think it was 10, well, you had one on 10 and on 11. So get that down. And then we're going to look into special cases and then for four-term polynomials. So when I'm referring to bottom up, it was right here. So like this number, -5, can go into 1. That's why it went up to the front. Okay. All right. All right, so let's go to the next tab, which is our special cases. So it is, we're on number 13. All right, this first one here, this is an example of a difference of perfect squares, okay? It's differences we have subtraction, so this is a difference of perfect squares. So if you have a subtraction between two perfect squares, so this is saying a number squared and another number squared, the way that it gets simplified is that you end up taking the square root of the first one. So if I were to take the square root of a squared, it would just become a. Okay? And you also take the square root of the second one. So it ends up working out to be a minus b and a plus b. Those are, you just have a plus and a minus when you take those square roots. So what you just got to do is check that each term that has a subtraction between it is a perfect square. So for example, here, 9 is a perfect square. The square root of 9 is 3. The square root of x squared is just x. The square root of 16 is just 4. So because all three of these things are perfect square, then the answer here would just be 3x minus 4 and then a 3x plus 4. So if you recognize that the number is a perfect square, you just have to put a plus or minus between the two factors. Okay. If you're not sure, you'll have to just check on the calculator. Like on the calculator, there is a square root symbol, and it has to give you a whole number answer for it to be a perfect square. So the square root is over here by the 7. It's where the x squared is. Let me get out of this. So you have to hit second and then x squared and then put the number in to check. Okay. So if it gives you a decimal, then it's not a perfect square. So you can't do this. Okay. But if you know them by heart, then it's just working it out. So like I can take the perfect square of this first term all at once. 25n squared comes out to be 5n. 81 is a perfect square. The square root of 81 is 9. So my answer here would be 5n minus 9 and then 5n plus 9. So if you just recognize right off the bat, then you can just take the square root of each number and just put 1 plus and 1 minus. Now, if you don't see a perfect square, but you see this minus sign, you might want to check to see if it has a GCF first. These two terms have a greatest common factor of 2. So what I'm going to do is I'm going to divide everything by 2 first. Now when I do that, I have a 4, which I know is a perfect square, minus 9g squared, which is also a perfect square. Question. So if I take the square root of 4, that's 2. Square root of 9g, that's 3g. So 2 minus 3g, oops, forgot something, sorry. Forgot something. I forgot to keep the GCF. So the GCF goes on the outside of the parentheses. This becomes 2 minus 3g and 2 plus 3g. So you keep the GCF in the front. This was your GCF. When you divide by a number, a term, or a variable, that goes in front of the parentheses. Trinomials. All right, so then the next two are types of special trinomials. This is when you have to look at your first and your last term to see if it's a perfect square. And if it is, and you have a plus sign through all of them, then the way you break it down is you take the square root of the a, and this would end up giving me a, because there's plus here, you just put a plus b parentheses squared. Now, if there is a minus in between the first two terms, then this would be a minus b parentheses squared. Now, when you do this, you always have to check the middle term. You have to check the middle is twice, 2 times whatever a and b is. So if you look at this first one, number 16, my first term is x squared. If I take the square root of x squared, that's just x. Okay. The last term is 9. The square root of 9 is 3. So what I have to do is check the middle. Okay. Check that the middle that I have here is 2 times x times 3, which it is. 2 times x times 3 gives me the 6x. So since all three things work, then my answer for this is just taking our two square roots, x, and because there's plus signs there, so we just say x plus 3, parentheses squared. So I checked the first term. Yep, that is a perfect square. Square root of x squared is just x. I checked the last term. Yep, that's a perfect square. Square root of 25 is 5. Then I checked the middle. if I multiply these together times 2, does that give me 10x? Yes. So this, because now this one had a minus sign here, between right here, then you're just going to say x minus 5, parentheses square. Okay. So if there's a plus sign between the first two terms, or all of the terms, it's going to be plus. If there's a minus sign, then there's going to be minus. So on this one, our first term, if I take the square root of 4g squared, that's just 2g. The square root of h squared is just h. 2 times g times h, then double that. Yep, that gives me that 4 right there. So it's true. So my answer here would be 2g plus h parentheses squared. All right, I want you to do 19.
So you always multiply by 2 to find
the middle. Yeah, you double it to make sure it's the middle one. We just multiply them by 2. All right, so you're going to do 19. I'll check that when you turn this in. And then just got to know we have 2 types here. We have a difference. Oops, man, I can't go. Difference of perfect squares. Or you're going to have a perfect square trinomial. That's when you're going to have, if it's a trinomial, you're going to have the middle term. So if it's a trinomial, you just got to make sure you check for this middle. It's twice that perfect square. There's twice of those perfect squares. All right, and then our last way of factoring, and you can do this with trinomials too. This last one you can use for always, all different ways, I guess. Okay, so on the last tab, number 20. Okay, so yeah, that's right. Yeah. Okay, so sometimes you're gonna factor instead of a number or letter. You might have a common binomial. Okay, 2 terms.
Can you go back up to the summary?
Yeah. Are we good? All right, so last section, 4 terms. Okay, number 20, this section 20 through 23 is an example of what we call factoring out a common binomial. Okay, so we're going to factor out a common binomial. A binomial is 2 terms, okay? So if you look right here, I see x minus 2 and x minus 2. This is the common binomial. that x minus 2 is your common binomial. Okay, so when we factor it out, we're going to divide everything by that binomial. So I'm just going to rewrite it here to show we have 5x, x minus 2, and plus 7 parentheses x minus 2. And I'm going to divide each term by that x minus 2. And you can kind of see this mentally when you do that. So when I do that, basically this cancels and you see you're left with what you have in the front of the parentheses. Okay, those terms in front are your factors. We're going to group these together. So this would be 5x, and because there's a plus sign here between the two of them, plus 7. That's one of my factors. And then the other one is going to be that common binomial. The common binomial was that x minus 2. So one of your factors is always the two they have in common, and the remaining is basically your lead term, your coefficient of that polynomial. So I don't necessarily have to divide. What I do is I just tend to always find the common binomial first. And so if I look like on 22, this y minus 2, and I know this is 2 minus y, well, what I can do to fix this so that they are the same, 3y squared, keep this as y minus 2, but if I want the y to be, see here the y is negative. I want it to be positive. So what I'm going to do is I'm going to multiply this by -1. Okay. When I do that to everything, this now becomes -4. And now I have y minus 2. Because a negative y becomes a positive y. And then a -1 times 2 makes that -2. So now I have the common binomial. That's my common binomial right there. So that's one of my factors. The other factors is just what's in front. So circle your sign too, because that helps to make sure you pick the right one. So my two factors are this 3y squared minus 4. That's what's in front of the parentheses. And then the other factor is the common binomial, y minus 2. And that's our factoring right there. So if you see a common binomial, you just take that out and put what remains in the other grouping. So like on 21, the m plus 3, that's my common binomial. So that's one of my factors. The other factor is what remains. I have a -9m and -5. So that's what's going in my next grouping. -9m, m minus 5. If it's not in the same order, okay, but it looks like it could be a common binomial, like on 23, to make it a common binomial, you got to multiply it by -1. You're going to multiply each thing, each term, each number by -1. So when I do this, this actually becomes, the first one stays, d minus 5. But this, a negative times this -3, that now makes that +3. And now I have d minus 5. So this is my common binomial. So that's one of my factors. And then the other one is your coefficient. So 2d plus 3. Now, seeing a common binomial, what we just did here is how you do a 4-term polynomial, okay? So this skill right here, seeing a common binomial, is important for the last part, okay? So on 24, okay, we now have 4 terms, trinomials, meaning there's basically between our plus and minus 1, 2, 3, 4. You have 4 terms, okay? The way you do a 4-term polynomial, you first group the first 2 terms together. So x cubed plus 2x squared. You group those 2 terms together. and then you group the next two. Plus 8x, sorry, plus 16. Sorry, I kind of ran out of room. All right, so first group the first two and the last two. Then you want to look for a GCF.
Does it have to be in order like that, or does it not matter?
It doesn't matter, as long as you do two groupings, okay? So now in each group, you want to check for a GCF. Well, if they don't both have numbers, okay, you have to just check you take out the smallest variable, okay? So both have an x, the smallest one is the x squared. So we're going to divide both of them by x squared. So the first one's GCF is the x squared. Then if I look at the second term, 8x and 16, the GCF between these two terms is 8. What we divide by is what's going to come outside the parentheses. So for this first group, it's going to be x squared on the outside of the parentheses, and we're just subtracting, we're just reducing. So this becomes x and then plus 2. On the next term, the GCF comes outside the parentheses. 8x divided by 8 is just going to leave me x, and 16 divided by 8 leaves me plus 2. Do you see now there's a common binomial between them? So that's what we could take out. That's my factors. That's one of my factors, x plus 2. The other one is just your coefficient that's outside the parentheses. So this would be x squared plus 8. And that is yeah, because you're subtracting. So you're saying 2 is gone, leaving you with 1x, and these cancel. Okay. All right, so first let's group these two. If you want to just do the parentheses up top, you can, like that. But I would just say make sure you pay attention to your sign, because there's a minus sign between them, so don't forget that, okay? All right, then what you do, yeah, check for the GCF between the two of them. Okay, so the GCF between our x cubed and minus 10 is 1. The only thing they have common is 1 here.
Which one? There's two sounds.
And then if I check for the GCF for this one, they have an x in common.
Did you not include the negative sign in the 5?
Yeah, I am. I'm gonna put that negative.
Okay.
Wait.
Do you have to put the one on the outside of that?
No, you don't. But I'm gonna check something real quick. So I want to see. This is 5 plus 2x. Because I think I can factor this some more. I'm on this x. Oh yeah, because look. Okay, yeah. Look at this. What happened? So when I do that, these are not common. You don't have a common binomial. Okay, so what you have to check when that happens is check your order. Okay, there's no common binomial here. Okay. So now we have to check the order of our terms. Okay. So basically, I need to make sure that polynomial or any polynomial, trinomial, whatever type, is in order from highest to least, to smallest. So we need to put into standard form. Just go high to low. Who's the highest exponent we have in this polynomial? Yeah, x cubed. So the x cubed is going to come first. who's the next highest?
2x30.
So then that one. Then we need just an x. That would be minus 5x. Then a number, minus 10. Okay. So now when I group these, now we're going to check to see if they have a common binomial. Because in this first group here, x squared is the GCF. And in this group here, 5 is the GCF. Before I had 1 and an x. So when I take out the GCF of the first group, now I have x plus 2. Put my minus sign. When I take the GCF here, I have x minus 2. And we just talked about that. So it is minus 2, right? Negative 5. Yeah, that's right. So in order to change this sign right here, all I got to do is, I did factor out a 5.
So the order you put them in does that?
Oh, wait, this should be plus 2. Yeah, the order does. Because you see how this was negative? This has to be negative times a positive to make that negative. So there are GCS. Yeah, you want it in standard form, high to low, so you can get to the common binomial. I forgot that sign. All right, so this would be x squared plus 2. X plus 2 is the first one. The common binomial. And then x squared minus 5. The number that's outside.
So why do you write it with the number on the outside? You're just gonna change it to that.
Then which number on the outside?
When you divide it by. Like when you divide by x,
Mhm.
divide it on the outside.
Well, I just kind of simplify. I do that just to make sure these come out to be the same. And if they're the same, then I know that's one of my factors. Yeah. hmm
Yeah.
So the thing here, we need to make sure to do 4 terms. First, it needs to be in standard form. That's when we go high to low.
You don't speak Spanish. Stop lying.
Okay. Then second, you're gonna put in groups into 2. So group the first and last. And then all we need to do is factor out a GCF. Once we factor out the GCF, then that's our 2 common factors. Okay. So whenever we have a 4 term, the key to this, I guess you could say, is you have to look for a common binomial. Four terms needs to have a common binomial. Okay. If you don't have a common binomial, then we can't factor it. Okay. We have to do it a different way. All right. So.
If we don't have common binomial, we just break that down.
Yeah. Most likely, because then you have to look at it through the graph.
Is this correct? I missed it when you did it.
Number 22. It should be this. Oh yeah, that's right. All right. Make sure your name's on this.